Hi everybody and welcome to the third practical for next generation genomics this year. This week we're going to be looking at long read assemblies. So this is the third practical out of 4. So as per usual, we have a discussion session next Monday from 11 till 12 and then again from 4 till 5 GMT. So please do have a go at the practical and then join for one of those sessions. We also have the discussion board, and if you pop a question up on there, either me or one of the demonstrators will be able to get to that question, hopefully in relatively short order, and help you out with any queries that you might have. So, what are the objectives for this week? First off, we'll be accessing our server as per usual, and then again, as per usual, we'll be finding the data on our system and making a soft link to it. Our data this week is rather large, so it's extra especially useful to link the data rather than copying it around the server. We're then going to assess the quality of our long reads, and again, this might seem like a kind of standard step, and you'd be right. We always tend to assess the quality of our raw data before going any further, and this is no different for long reads. So we'll be assessing the quality of our raw data, which comes from PacBio and Oxford Nanopore sequencing runs. And we'll be doing that with a different quality control tool this week called Nanoplot, which I'll talk about again in a moment. We'll then use a de Bruijn graph assembler to assemble our long reads. The tool that we'll be using this week is called WTDBG2. Now, or Red Bean for short. Now, WTDBG2 uses a slightly different algorithm than what we used to. It uses an algorithm called a fuzzy de Bruijn graph, and this is very useful for long read assemblies because it allows us to correct for some of the errors inherent with that data. We'll then assess the quality of the genome assemblies that we've made using our standard metrics, such as N50, and then we'll explore slightly the parameter space, i.e. we'll change some of the parameters and see how that affects our assembly output. So our quality control tool, Nanoplot, is a very useful tool for long reads. It gives us some very nice graphs of read length distribution as well as quality. And you'll notice we have to adjust our expectations somewhat when it comes to working with long reads. We don't get the same quality generally that we would find in short reads. However, we can still have a look at what qualities our reads come to and what the distribution of that quality is across our read lengths. So we'll use that quality control tool, and again, we'll produce some HTML reports that we can open in Firefox and have a look at some of the graphs produced and assess how good the quality of our reads are. We'll then go on to assembly. So we'll be using a de Bruijn graph assembler, but we'll be using one with a slight difference. So you should now be used to the idea of de Bruijn graphs and the way in which they assemble reads by breaking our reads down into k-mers, forming vertices and edges, forming a graph, and then simplifying or solving that graph. But this time around, we're going to be using an assembly tool that uses something called a fuzzy de Bruijn graph. Now, WTDBG2 has a Nature publication that you can go and read if you want to learn more about the specifics of how this works. But what it is essentially is a de novo assembler using essentially a de Bruijn graph algorithm, but a de Bruijn graph algorithm called a fuzzy de Bruijn graph. Now, this allows us to correct for some of the errors that we get in Nanopore and PacBio long reads. And it does this by making alignments of our reads or alignments of chunks of our reads before making its De Bruijn graph. This allows us to compensate by that alignment for the errors that we encounter. And it's actually relatively fast compared to other long read assemblers. It's still a very fast option, so we can actually do some meaningful assembly in this practical, whilst with some fairly chunky data sets. So that said, there will be some points at this practical which do take a little while. So sometimes for half an hour to an hour's time running on our server, with the number of threads specified. The reason why we've specified that number of threads to use is that we want to try and keep enough headspace so that several people can do this practical simultaneously. And if we were to run it faster, then we would potentially take up all of the cores on the server and no one else could work on it. So we don't want that. So be patient with these assemblies. You can always set them running and come back to them the next day or after you've done some work or after lunch, or you could use the downtime to do some reading, maybe read up on how the assembly tool works, or do some other work. So you can kind of set this up and hopefully get it running and in the background. So more about this fuzzy De Bruijn graph. So essentially how this works is by taking our very long reads and breaking them down into smaller chunks. So smaller fragments for red bean at the moment, I think, is 1064 bases. It breaks these, it takes these chunks and does a pairwise alignment, so it matches similar chunks together before constructing its De Bruijn graph. So you'll notice from this diagram that the vertices are actually made up of small alignments of chunks rather than singular pieces of reads or k-mers. So this allows us to correct for errors. If you look at this graph, you can see that we can correct for some of those gray boxes or unknown boxes by aligning first before we make our graph. We can then go through a graph cleaning step to form our consensus sequence. So this allows us to create an accurate assembly despite the fact that we have lots of errors in our original raw data. So our practical document is the same as it has been the last couple of weeks. You have instructions or you have code in the I believe actually blue boxes for this practical, but in boxes, and then some highlighted pink for kind of optional bits that you might want to do. So it should all be rather self-explanatory and similar to what we've done the last couple of weeks. But as always, any questions, do get in contact with us on the discussion board, and we'll hopefully get to any questions you have as soon as we possibly can. We look forward to seeing you on Monday in one of those sessions, and we can discuss exactly how these assemblies looked once we ran them, and what our parameters or effect our parameters have on those assemblies. So good luck with the practical, and let us know how you're getting on the discussion board or in our session on Monday. It'd be good to have as many questions as possible on the Monday live sessions so that we can have a good lively discussion. So I look forward to seeing you all there, and good luck with this practical. Yeah, let us know what you think.